So let's convert this fraction into its partial fraction. Let's resolve it into its partial fractions. So simply, you'll just look at one thing over here. What type of partial fraction resolution are we talking about? Well, the variable x over here has a power, the power of 2. So you'll automatically assume that this is the third type of partial fraction resolution. So if you remember, this is how you resolved a single fraction in the third type of partial fraction resolution. You had one partial fraction, that had ax plus b in the numerator, and in the denominator it had the expression which had the variable x with the power. So the x squared plus 2x plus 5 will have a numerator of ax plus b. And then we have to deal with this second linear expression, and obviously the second partial fraction will have c over the linear expression. Now you have to make the denominator of the left hand side and the right hand side equal to each other. So you'll take the LCM on the right hand side. So ax plus b will be multiplied with x minus 1. C will be multiplied with x squared plus 2x plus 5. And so now you have the denominators equal to each other. You'll cancel out the denominators, and then you'll equate the numerators to each other. And that's where you get this equation number 2. Now, after expanding and calculation, this is the final equation, which is equation number 3. Now, when you put x is equal to 1 in equation number 2, what happens? Well, this is equation number 2. And when you put x is equal to 1 in this expression, this part, this linear expression becomes 0. 1 minus 1, 0. And since this becomes 0, this ax plus b will be multiplied with 0, and it will also become 0. And now, when you plug in x is equal to 1 over here, and over here, and over here, you basically get this. So now, after doing all the calculations, you can see that the value of c is equal to 2. Now, we'll equate the coefficients of x squared and x on the left hand side and the right hand side. So we'll use equation number 3. So how will we go about this? Well, as you remember, look over here. The coefficients of x squared are a and c, and the coefficients of x are a, minus a, b, and plus 2c. So basically, when you simplify this expression on the right hand side, you'll get a plus c into x squared plus minus a plus b plus 2c into x and minus b plus 5c. So you can see that the coefficient of x squared on the right hand side is a plus c, and the coefficient of x on the right hand side is minus a plus b plus 2c. So a plus c on the right hand side is equal to 1 on the left hand side. Since the coefficient of x squared on the left hand side is 1, a plus c is equal to 1. Now, since a plus c is equal to 1 and we already found the value of c, when you plug in the value of c as 2, you get the value of a, which is equal to minus 1. Now let's find the value of x. As you remember, the coefficient of x on the right hand side is minus a plus b plus 2c. And on the left hand side, we did not have an expression for x. Look over here. Oops. Yes. As you can see, there is no expression for x on the left hand side. So the coefficient of x on the left hand side is 0. So minus a plus b plus 2c is equal to 0. We already found the values of a and c. So when you plug in those values, you'll get the value of b as equal to minus 5. Now we found the values of c, b, and a. When you plug in those values, you get these partial fractions. And so you've resolved the original fraction given in the question into its partial fractions.